So for today, we are doing circle trig, and let's just make sure you can do regular trig before you can do circle trig. Because if you can't do this, don't even need to go on to that. So if this is a 30, you should know everything about this, including how long the side ratios are. You know those little numbers that go on the side? I sometimes say it's almost as easy as 1, 2, 3. Okay, and you should have put 1, 2, and the square root of 3 on here. Raise your hand if you had that one right. Okay, awesome. Next, would you agree that there was a 60-degree angle up here that I never really mentioned? Now, how do you know which is the important angle? You can't really tell from this. We've just never done sine of the 90-degree angle. We sometimes use the 30, sometimes we use the 60. Well, one of these is always going to be close to the center of a circle today because it's called circle trig. So like your triangles are going to be in a circle like this, and the angle that's close to the middle of the circle, that's the key one. Let's try to remember that. That's the first of many little facts for today, is how do you tell which is the important angle? Well, if this was at the center of a circle like this, it's a terrible circle. It would be at the center of the circle, Mr. Server. That'd be more like there, more like that then. The one that's at the center of the circle, that's the important angle. And all the answers are from that perspective. Okay, so that's called the central angle. It's by the center of the circle. All right, next thing I want to draw for you is this. Everybody draw this, and let's make an angle. I said 30 was probably the most important angle because it's pi over 6, and you guys got to be good at that now. So if I say 5 pi over 6, you got to go, oh, so you mean 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is over this one, the red one here. That's 5 pi over 6. So anyway, you need to know what pi over 6 looks like, also known as a 30. And let's draw a triangle around that. Do. Okay. Do you get which of the angles is the important one then? It's the one that's by the center of the circle. And I know you're like, what circle? Well, this is the center for sure. If we were going to draw a circle, it would go around like that. Circle trig is starting to develop here. All right, next, I'd like us to just put a theta right here. And then let's imagine we didn't know how long these sides were. I could still call this x, and I could call this y. Because x is at a cross kind of distance, and y is an up and down kind of distance. Now, in the unit circle, unit means 1. So if I asked you for the unit rate, you bought a bunch of peaches at Cub. You come home and you got like 7 peaches and you paid a certain amount for it. The unit rate means how much for 1. Unit circle, radius is 1. That side right there is 1. Okay, the hypotenuse is 1. Then, this one kind of blows people's minds. You now have to understand that sine of that angle, sine is the opposite over the hypotenuse, right? So what's the sine of that central angle? Y over 1. What's the cosine of that central angle? X. Do I even have to put over 1? Because over 1 just means like you leave it alone, right? So sine is really just y. I'm going to actually erase this out because I don't need that 1. It is y divided by 1, but that's just y. So the sine is always the y value, and the cosine is always the x value, if the radius is 1. By the way, what's tangent then? Well, it's TOA, Mr. Sir. Opposite over adjacent. What's the opposite? Y over what's the adjacent? X. Tangent's y over x. Okay, if you can just memorize one of them, it's huge. just like before I said 30 is the key angle, right? If you could just remember that sine is y, sine y, sine, S-I-N-Y, something. Just memorize sine as y. It's really, really, really handy. Because then you'll go, what's cosine? Well, it's the other one, x. So if you just remember the sine is y, you'll probably not think that cosine is also y. That wouldn't make sense. Sine is y. Okay, and we're getting to why you care in a second here. Now I'm going to erase off the y and the x. And I drew this on purpose to make the angle look like it's about 30. If it's about 30, would you agree that I could put in 1, 2, and the square root of 3? Everybody do that. But wait. If it's really the unit circle, then what's wrong? Remember what unit means? If you haven't written this down, it's a really important thing. Unit means 1. So unit circle means the 1 circle, which means the what's 1? The radius. Is the radius of the circle 1 the way I just drew it? No, so here's how you fix it. You can't just like erase the 2 and make it a 1. That wouldn't make any sense. I got to keep my side ratios the same. What do you think I'm going to do to all the numbers? To make it so the radius will be 1, I have to do something to all the numbers. I'm going to divide them all by 2. Because isn't 2 divided by 2 equal to 1? Okay. Now, let's see if you can put this all together. What's the radius now again? 1. What's sine? What letter? Do you see where the y value is? It's 1/2. What's the cosine of this thing? Root 3 over 2. And you're doing it different, Mr. Server. You're just like grabbing a number. You're instead of having to do cosine, adjacent over hypotenuse, you might be like, but shouldn't I divide it by the hypotenuse? Yeah, but the hypotenuse is 1. Okay, then last little piece, see if you can put this together. This spot right here is a point. You would start at 0, 0 to get there, and you could go to the right, root 3 over 2, and up 1/2. That point is root 3 over 2, comma 1/2. All right, that's a lot. What's the sine? The sine is the y. I know, because you told me to memorize it. Sine is y. I got it. Sine is y. Well, of these 2 points, or the 2 parts of the point, which one's the y? The root 3 over the 2? Or the 1/2? Which one's the y? It's the 1/2. So in this circle, sine of theta is the y, which is 1/2. And the cosine, well, that's the x of the thing, and the x is the first point, so it's root 3 over 2. I'm teaching you to think differently than just cosine, adjacent over hypotenuse. Even though that's still important, and that's still a thing, you have to know that sine is y and cosine is x. Because now that allows us to go to a place like this and say, if we're on the unit circle, would you agree that is the point 0, 1? If we're on a unit circle. Do you get how this dot right there would be 0, 1? Yes? Okay. Then what's the sine at that spot, which is, by the way, 90 degrees, also known as pi over 2? What is the sign there? What letter is sign? It's y. So sine is 1. I'd like you to take your calculator and type in sine of 90. Make sure you're in radians mode. Sorry, degree mode. Degree, sorry. Make sure you're in degree mode. And then type in sine of 90. Did you get 1? I just showed you why it's 1. What do you think the cosine at 0 is? Sorry, I said it wrong. What do you think the cosine at 90 is? In this spot right here, what's the cosine? Say it. 0. Everybody type in cosine of 90. See what you get. Seems to be working so far. How about tangent of 90? Isn't that the y over the x? Which would be 1 over 0? Is 1 over 0 even a thing? Then try typing tangent of 90 and see what happens. Be careful, your calculator's going to explode. Do you get how tangent of 90 isn't a thing? You can't do it. Why? Because it's 1 over 0. And it can't exist. Okay. So if I told you another point, like over here, if I just told you, hey, that point right there, if I just told you that that point over there was negative root 3 over 2 comma 1/2. You didn't know anything else. Then what's the sine of that angle? One half. What's the cosine of that angle? Negative root 3 over 2. What's the tangent of that angle? It's that divided by that, which looks weird, but do you remember me saying there'd be a reason why you'd have to know fraction over a fraction? 1/2 over negative root 3 over 2. And then you flip and multiply. And then I'm going to go times by and put the 2 on top and the negative root 3 on the bottom. And then this cancels, and then it's 1 over negative root 3. Negative 1 over root 3. Now, what I was drawing for you there was this triangle. And that triangle is a 30, 60, 90, with sides 1, 2, square root of 3. But wait, it's actually negative square root of 3. Why? Because you're going to the left. So what's sine of 30? Watch. Sine is opposite over hypotenuse. Look at that. It's the 1/2 we got earlier. What's the cosine of it? Cosine of 30 is negative root 3 over 2. That's this. See what I mean? So if I give you any point, the sine is the y of it. The cosine is the x of it. And the tangent is the y divided by the x of it. I'm going to give you another point. Down here, if we're on a unit circle, is that 1 comma 0? No. It's what comma what down there? 0 comma negative 1. So I'm going to save you some time. That's 270 degrees. What's the sine of 270? What's the sine of 270? Yeah, sine's the y. Sine of 270 is negative 1. I want you to check it. Make sure I'm not losing my mind. Go to sine of 270. Sine 270. Did you get negative 1? Yep. What's the cosine of it? 0. What's the tangent of it? Tangent is negative 1 over 0, which doesn't exist. Okay. Now, that works all a really good system, but I'm afraid that if I just give you a random one, like, oh, let's say the cosine of 5 pi over 4, that you might not be able to do it because you might not be able to draw the right triangle that is involved. But I'm going to do this first one for you, and then I'm hoping you catch on. So everybody, do this with me. The first thing you always do is make a circle like this with an XY axis in the middle of it. Next, you're going to try to figure out where 1 pi over 4 is. Not where 5 pi over 4 is. If you can't figure out where 1 pi over 4 is, you're toast. So where's 1/4 of the way to pi? I hope you realize pretty quickly it's right there. That's 1/4 of the way to pi. That's 1 pi over 4. This is 2 pi over 3 pi over 4, 4 pi over 4, 5 pi over 4. There's where 5 pi over 4 is. This is why I didn't want you to get behind in this unit, because now I'm relying on you to be able to know where 5 pi over 4 is. Okay, so now we're going to make a little triangle. This is called, by the way, a reference triangle. And do you happen to know one of the angles in here? Well, it's a 90. That's easy. But one of the other angles? The key one is the central angle. I know it already. Does anybody else know it? This angle right in there. This little guy, I'm going to make it red. Neil.
45.
That is a 45. How do you know that? Well, you probably just know that this is a 45, right? In the first place. So all of these little wedges are 45s. That's a 45. If that's a 45, this is a 45. Now, would you please label all the sides? Be careful. One of them's, at least one of them, is negative. It's easy to forget that. Because some kids are pretty good at the, oh yeah, that's the 1, 1, square root of 2 triangle. But then they go 1, 1, square root of 2, and then sadly, you just lost some points on the test. Why? Because that's negative and that's negative. That is the #1 most common mistake on this next test we're about to do. It's the most common mistake in circle trig. Forget that negative. It's just so easy to do. You're in the middle of so many things, you forget the negatives. Dang it. All right. Now, yes?
Why isn't the square root of 2 negative?
The radius always is going to stay positive.
Oh.
Here's a way to think of it. It's a distance. Of course, the other things are distances too. But it's a distance, and that distance has to stay positive. The other ones are directional, but we never talk about what direction the hypotenuse is going in. So the hypotenuse will always stay positive. I don't have a really good answer for you. In fact, somebody just asked me this the other day. And I could give you a really long answer, but I don't think it's worth it. So just for right now, we got so many things to cover. Trust me, hypotenuse is always positive. Okay, so back to what were we doing this for? Because I said you'd be able to find sine of 5 pi over 4, or cosine of 5 pi over 4, or tangent of 5 pi over 4, and I was a little concerned you wouldn't be able to draw the triangle. But now that you've got the triangle, there's 2 ways to do it, and I'm going to do it the normal way first. Isn't sine just the opposite over the hypotenuse? And so from this 45-degree angle's perspective, that's the boss one. Sine is opposite over hypotenuse, so -1 over square root of 2. Raise your hand if you had that one right. Awesome. Cosine is adjacent over hypotenuse, and it's actually weirdly the same. And then tangent is TOA, opposite over adjacent, which is -1 over -1, which cancels off and makes just 1. Now, are you feeling okay about that? Does that make sense to you so far? Sine is opposite hypotenuse, cosine is adjacent over the hypotenuse, tangent, opposite over adjacent. Okay. Now, what if I changed all the numbers? Why the heck would you do that? Because this wasn't a unit circle problem right now. Why not? Because is the radius 1 right now? No. But don't change everything. The answers are going to stay the same. Weirdly, they're going to stay the same. But just hear me out. If I want this radius to really be 1, then I have to divide it by the square root of 2. But then if I do that to one of the sides, I have to do that to all of the sides. And the cool thing is, now, if I do my opposite over hypotenuse again, it's still going to give me the same answer. Because isn't the hypotenuse just 1 now? And if I do the opposite over the hypotenuse, I still get negative 1 over root 2. See what I mean? Isn't that weird? I divided everything by the square root of 2, and I still get the same answers as before. Cosine, adjacent over hypotenuse, which is negative 1 over root 2 over 1, which is negative 1 over root 2. Cool. Why would you need to jump through that hoop? Because then you can label this point right here as that's the x value, and that's the y value, and the sine is the y value. Look at that. The sine is just the y value. The cosine is just the x value. So that point right there has got a name, and it is something comma something. The x value of it was negative 1 over root 2, and the y value was negative 1 over root 2. And if you've got that in a point form, it's super powerful because that's the sine, that's the cosine. And the tangent is dividing them both together, which since they're the same, it's equal to 1. Whew, that's a lot. Look at that. Just look at that drawing. There's so much to this. It's complicated. This is one of the reasons that I warn people about second semester is harder than first semester. I'm not saying it's impossible, and I think most of you are following it. I think you're getting it, but man, this is intense. So I just need your best. And that includes doing some homework on this, or it's just so intense. If you just kind of get lost here in the first couple days, you can get really lost in this first test. And then you will have to retake it because this test is what everything else for the rest of the semester depends on. But remember me starting the hour, I said you might feel a little lost at the end of today, but it'll get better. All right, so let's try some that are kind of easy. What if they give you the point? Like, if this is a unit circle, I know these 4 points like the back of my hand. If it's really the unit circle, then this distance is a 1, isn't it? So isn't this 1 comma 0? And this spot is at 0 degrees. What's the sine of 0 degrees? Which letter is it? Which letter is it? Sine is what?
Y.
Sine is y. So what's the answer?
0.
Sine of 0 is 0. What's sine of... Well, no, what's cosine of 0? 1. What's tangent of 0? It's 0 over 1. And a lot of people are like, is that allowed? Is that allowed? Yes, it is. 0 over 1 is allowed. What's 0 divided by 1? 0 divided by 1 is 0. So, what do you think you get when you type in tangent? Try it. Tangent of 0. It's just 0. Because it's 0 divided by 1, which is 0. So if I give you this point right here, would you agree this is 0 comma 1? That's 90 degrees right there, aka pi over 2. So many little things to know. What's the sine of pi over 2? 1. What's the cosine of pi over 2? 0. And what's the tangent of pi over 2? Can you do 1 over 0? Is that allowed? No, you can't have a 0 on the bottom. I like to think of it as if you are standing on a board and there's a ball underneath that board, you are going to fall. It's not going to work. However you want to think of it, you can't do that. So there's no tangent. He can't do tangent of 90. If you do it, it'll say error. Okay, so here's another point, except I'm not going to say it. Would you please tell me what the sine and the cosine and the tangent of pi are? Why didn't you say 180? Because pi is 180. What's the sine of pi? If you know what this point is, then you know what to put here and here, and you should know the answer. What's cosine? What's tangent? It's usually the part of the year where a lot of tutors get called. Because people are like, I'm totally not getting math anymore. So if you're feeling a little off, it might be that. This is just tricky. And after a while, you do enough problems, you get it. This should be -1, 0. Raise your hand if you knew that much. Cool. Then what's sine of this spot? Well, it's the y, so it's 0. What's cosine of it? -1. What's tangent of it? 0 over -1, which can exist. 0 divided by -1 is just 0. Raise your hand if you had 0, -1, and 0. Sweet. All right. Then ready for the ultimate challenge? Okay. Would you find sine, cosine, and tangent of 11 pi over 6? It's not that hard. 11 pi over 6. Hint, draw yourself a triangle. If you draw a triangle, always label it with its sides and its angles. Now, I'm sure you're thinking about drawing one of these, which, if you haven't already, do it. Draw a circle with an x and y axis through it, and draw the triangle in the right quadrant. In a moment, I'm going to ask you to compare that to the person next to you. So if you've been zoning, what you're looking for right now is 11 pi over 6, and you draw a line there, and that helps you draw a triangle there, and then you should be able to figure out the sides and the angles of that triangle. And be careful with the most important mistake. The most common mistake is that people forget the negatives. All right, I'm going to pause for a second, and then I'm going to see if you're drawing your quadrant, you're trying your triangle in the right quadrant. Okay, the kids are comparing with each other, and this is how you get to 11 pi over 6. It's this line right here. 1, 2, and the square root of 3. It's really easy to forget that that's -1 right there. That one's negative.
Yeah, did you get it?
And then this is the key angle. And then sine of that is the opposite over the hypotenuse, which is -1 over 2. And the answer is sine is opposite over hypotenuse, -1 over 2. Raise your hand if you had that one right. Okay. Now, some of you might be like, but Mr. Server, you said it was the unit circle. Actually, I never said that. You can use the unit circle, and let's just see how that would give us the same answer. I divide this by 2, I divide this by 2, and I divide this by 2, and then watch how this would work. Sine is the y, right? Which one of these is the y distance? All right, double checking myself. Opposite? Hypotenuse. Okay, sine is the y. Okay. Okay, so this spot right here on the circle, that spot there, would be √3 over 2, comma, -1/2. There we go. And which of them is the y? That one is. And this is a up and down distance, a y. And so the y would be -1/2 if I do it that way. And it's the same thing as I had before. All right, and the cosine then is the x, which would be √3 over 2. And the tangent is the y over the x, which is -1/2 over that. It's kind of gross, but it's right. That's why it's on the top 20. Timesing by, flip this over, root 3 over 2. And I've changed that problem into that. No, I didn't flip it, darn it. It's 2 over root 3. And then those cancel, and the answer was negative 1 over root 3. Now, I want to remind you, there are some people, including the people who wrote our textbook, who are obsessed with never letting there be a square root in the denominator. So what they do is they do this every time there's a square root. They multiply by the square root, and this ends up being negative root 3 over, that's really root 9, which is 3. And this answer that I circled in blue is right. And so is this answer that I circled in blue. Both of those answers are the same. And I know that's weird. But get used to it, because that happens even on the ACT test. Because people like to not have irrationals in the denominator. So they do this little step. And sometimes you're like, but my answer looks different. And then you go, oh, they did that rationalizing the denominator thing. Okay, that was a lot. Now, what do you think would help make it stick? Doing a couple practice problems tonight. All right, so I'm going to show you the first couple. Oh, the unit circle that just flashed by there, we'll see that more in the future. And yeah, that would be a cool culmination. We'll do that tomorrow. All right, so right here, we've had plenty to learn today. It wants the sine and the cosine. They aren't even asking for tangent. Yay, I went one step further than I had to. So how am I going to do 0? Well, that's supposed to be 0 degrees. So where's that? That's out here. So if you're going to make a triangle for that, you're better than me, because I can't make a triangle for that. But I can make a point. What comma what's over there at 0 degrees? 1 comma 0, correct, sir. And now I do sine is the y of it. So sine of this angle is the y of it, so it's 0. And cosine of this angle is the x of it, so it's 1. Cosine of 0 is 1. Sine of 0 is 0. Cool. For this next one, pi over 4. If you don't know where pi over 4 is, I just want you to think about where pi is and think about 1/4 of the way there. 1/4 of the way to pi. It's like 1/4 pi. Oh, that's here. That's like a 45. Ooh, I know that one. 1 root 2. Here's the key angle. What's the sine of that? Ooh, I can do that. Sine's opposite over hypotenuse. What's the cosine of that? Oh, it's adjacent over hypotenuse. They happen to be the same thing. I hope you've got the idea. So what if you can't draw a triangle? Then you make a point. And the sine is the y of the point. And the cosine is the x of the point. Okay, that was tough stuff. If you're leaving here not feeling like, why didn't I move to regular pre-calc? Then I'm happy. Because you get smarter tomorrow and the next day, the day after that, and we have several days before our next test before you have to have it all down. But please, 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 for your own sake, practice tonight.